Water is the liquid of life. We drink it, we bathe in it, we farm, cook, and clean with it. It's the most abundant molecule in our bodies. In fact, every life form we know of would die without it. But most importantly, without water, we wouldn't have iced tea. Iced tea. Why do these ice cubes float? If these were cubes of solid argon in a cup of liquid argon, they would sink. And the same goes for most other substances. But solid water, aka ice, is somehow less dense than liquid water. How's that possible? You already know that every water molecule is made up of 2 hydrogen atoms bonded to 1 oxygen atom. Let's look at a few of the molecules in a drop of water, and let's say the temperature is 25 degrees Celsius. The molecules are bending, stretching, spinning, and moving through space. Now, let's lower the temperature, which will reduce the amount of kinetic energy each of these molecules has. So they'll bend, stretch, spin, and move less. And that means that on average, they'll take up less space. Now you'd think that as the liquid water starts to freeze, the molecules would just pack together more and more closely. But that's not what happens. Water has a special kind of interaction between molecules that most other substances don't have, and it's called a hydrogen bond. Now remember that in a covalent bond, 2 electrons are shared, usually unequally, between atoms. In a hydrogen bond, a hydrogen atom is shared, also unequally, between atoms. 1 hydrogen bond looks like this. 2 look like this. Here's 3, and 4, and 5, 6, 7, 8, 9, 10, 11, 12. I could go on. In a single drop of water, hydrogen bonds form extended networks between hundreds, thousands, millions, billions, trillions of molecules, and these bonds are constantly breaking and reforming. Now back to our water as it cools down. Above 4 degrees Celsius, the kinetic energy of the water molecules keeps their interactions with each other short. Hydrogen bonds form and break like high school relationships. That is to say, quickly. But below 4 degrees, the kinetic energy of the water molecules starts to fall below the energy of the hydrogen bonds. So hydrogen bonds form much more frequently than they break, and beautiful structures start to emerge from the chaos. This is what solid water, ice, looks like on the molecular level. Notice that the ordered hexagonal structure is less dense than the disordered structure of liquid water. And you know that if an object is less dense than the fluid it's in, it will float. So, ice floats on water. So what? Well, let's consider a world without floating ice. The coldest part of the ocean would be the pitch-black ocean floor, once frozen, always frozen. Forget lobster rolls, since crustaceans would lose their habitats, or sushi, since kelp forests wouldn't grow. What would Canadian kids do in winter without pond hockey or ice fishing? And forget James Cameron's Oscar, because the Titanic totally would have made it. Say goodbye to the white polar ice caps reflecting sunlight that would otherwise bake the planet. In fact, forget the oceans as we know them, which at over 70% of the Earth's surface area regulate the atmosphere of the whole planet. But worst of all, there would be no iced tea. Iced tea.